students are still joining. We'll wait for 1 and 2 and then we'll start. Okay, now we'll begin. So firstly, welcome to the course Fundamentals of Manufacturing Processes. In week 1, we'll start with understanding of manufacturing processes. So firstly, this course is offered by Professor D.K. Dwivedi from Department of Mechanical and Industrial Engineering, IIT Roorkee. I am your TA Alka Jangid from IIT Kanpur. Okay, so firstly we'll go through some assignment questions, sample assignment questions. You are given assignment to solve this week. We won't be solving those questions, but questions which are similar to those. So while solving these, you'll be getting some idea how to solve your current assignment, and also after this assignment questions, we'll go through some lecture notes. So first question is, the automobile component like crankcase is manufactured by. So your options are casting, welding, forming, and all of these. So these are some of the manufacturing processes that you have studied this week. So in case of crankcase, it is very complex part of automobile. In case of automotive engine, so this complex type of shapes, they are mainly made by casting. So the answer will be casting. So you also try to solve the questions. If you know some answer, you try to write those down in the, you can ask any question if you don't understand continuously, and also you can tell what is the expected answer. Okay, so in this case the answer is casting. So in this case, for better strength and fatigue properties, crankcase of automobile is made of casting, and due to the oil and cooling channels required for cooling and lubrication purposes, the crankcase is the most complex cast part in the combustion engine, and the cavity free casting can only be achieved through the use of sophisticated casting technology and precise compliance with pouring and cooling times. So there are also some different type of casting techniques such as pressure casting. Those are used for making these complex type of shapes. Question is not visible. So the presentation is not visible to you at all? Is it visible now? Let me know. You can unmute and tell. Okay, now it's visible, right? So when I'm going to the full screen size, is it now visible in full screen? Full screen mode, is it visible? Please type down the answer. Yeah, okay, thank you. Next question is related to surface finish. So the best surface finish and close control over the tolerance of the casted components can be achieved by, and your options are machining, lapping, shaping, and milling. So you can guess what is the answer, and you can tell what can be the reason. So you can unmute yourself and tell. Any guesses? Okay, so answer will be lapping. So lapping is one of the surface finishing mechanisms. So lapping is a machining process in which two surfaces, the surfaces that are given here, in between there is abrasive particles. So these particles are kept in between, and on this type of the relative motion, it leads to surface finish of the some components. So lapping is a machining process in which two surfaces are rubbed together with an abrasive between them by hand movement or using a machine. Lapping machine and lapping often follows other subtractive processes with more aggressive material removal. So in this case there is less material removal compared to milling and grinding. So these are the initial. Okay, someone else has joined. Let me admit. Okay. Yeah, you're correct, Akash. Answer is lapping. So this is a surface finishing process, lapping. Okay, so it is a subtractive process with it is follows other subtractive processes such as milling and grinding, which removes higher amount of material compared to lapping. So lapping is it comes after these processes. Next question is, powder metallurgy involves shaping and sizing of raw materials to achieve a specific shape and dimensions, which are used in the form of solid, liquid. This after form of there is a blank. So blank will be solid, liquid, powder, or all of these. So you can type your answers. Solid, liquid, powder, all of these. Which one should be the answer? I'll be checking the answer in the chat, then I'll, yeah. I'm going on the back slide because if it will show the answer on this slide. Okay, so answer will be powder. So in powder metallurgy, first step is formation of powder, and then you using this powder you consolidate it into a shape of the final product. Then you provide sintering. Sintering is heating of this product. Someone else has joined. Okay, admitted. Yeah, okay. Okay, so those who have joined late, we are trying to solve some sample assignment questions. So if you know the answer, you can type it in the chat, and if you have any query, you can ask in chat or you can unmute yourself and ask. So in this question, third question is, powder metallurgy involves shaping and sizing of raw materials to achieve a specific shape and dimensions, which are used in the form of solid, liquid, powder, and all of these. So answer will be powder. So in case of powder metallurgy, it is a process which consists of mixing elements or alloy powder, compacting the mixture in a die, and then sintering or heating the resultant shape in a controlled atmosphere. And the powder metallurgy is a highly developed method of manufacturing ferrous and non-ferrous materials, and it is a chipless working process. So in casting, after casting you machine this product. So some machining is required to provide better surface finish as well. And in case of metal working, there is there is also not many formation of chips, but chips will also form mainly forming in machining. So compared to that, powder metallurgy is a chipless working process. Someone else has joined. Okay. Okay. Someone else has joined. Okay. So powder metallurgy, you can understand. Firstly, you make powder of some metal, then you mix those two different metals to make alloy, or you can make pure metal as well. After that, you put that powder in some die, then you sinter it. Sinter meaning you heat it. So there will be formation of bonding, chemical bonding will be there, and then after heating you will be getting the shape of your final product. Next question is, the process in which mechanical properties don't limit the capability of the process. Your options are machining, forming, casting, and all of these. So which one do you think is the answer? Please type it in the chat. The process in which mechanical properties don't limit. So there are some processes where mechanical properties limit your capability of process. For example, in machining you require some hardness of the surface, you require some ductility, so all those mechanical properties come into play. But in case of which of these techniques, machining, forming or casting, these mechanical properties don't play any role. So the answer will be casting, because in case of casting it is done at melting point. So after melting it will be in solid, it won't be in solid state, right? So if it's in liquid state there won't be any mechanical properties won't be playing any role. Someone else has joined. Okay, no, all of these won't be correct, Akash. In this case, for example, in case of machining you require certain amount of hardness of the surface. Okay, so you require some properties and you require it in comparison to your machining tool. So machining tool should have higher hardness compared to your component. So these type of properties play role in case of machining as well. In case of forming, where you bend your material, so for bending also you require some type of bending properties. So casting will be the correct answer in this case. Someone else has joined. Okay, okay, so in case of mechanical properties they are important in case of machining and metal working processes, but in case of casting there is, okay, so those who joined late, we are trying to solve some sample assignment questions which will be helping you in solving your current assignment. So casting is done at melting point where the material is not solid, so mechanical properties don't play a role in casting. Next question is, in the casting process the material is heated above the, now what is the temperature that you heat your material to in case of casting? So your options are recrystallization temperature, ambient temperature, melting point or lower critical point. So type your answers in chat. So even if you're wrong, you will be learning like where you are going wrong, and mostly you learn more when you do any mistakes, right? So please type your answers in the chat for this question. In casting process, material is heated above the recrystallization temperature or ambient temperature or melting point or lower critical point. Okay, so answer will be melting point. So as I told earlier, in case of casting process you take your material in liquid state. So to make it in liquid state you need to heat it above melting temperature. So you require some heat, superheating as well. So you heat it little bit higher than the melting temperature. So in casting, to cast a material in the desired shape, casting is done, and metal casting is the process of making objects by pouring molten metal into an empty shaped space, which is known as mold. Okay, so what were the answers that you told? Okay, recrystallization temperature you use in case of, for example, other, when you'll be studying about heat treatments and all those processes, then you'll be learning about this, what is the use of recrystallization temperature. So in case of when you heat your material above ambient temperature, then that is known as warm working, and if you heat it above, even its recrystallization temperature, then it is known as hot working. So there are various these terminologies that you use in different type of processes. and lower critical point temperature. This comes into play when you be studying about surface hardening and heat treatment. Okay, so those who have joined late, we are trying to solve some assignment questions, sample assignment questions. So try to answer the questions. Okay, so next question is match the following. So you have studied about the manufacturing processes in this week and what those operations are. So try to match these. So first column has casting, forming and machining, and operations are material removal, melting of material and plastic deformation of the material. So you try to join these, and by joining which combination will be appropriate, you try to figure it out. Okay, so someone else has joined, so I have to go to previous slide, otherwise the answer will be revealed. Okay. Okay, try to work out this problem. Okay, so in this case we can see that casting will be melting of the material. So as I told earlier, you melt your material above in liquid form. Okay, so this is melting of the material will be casting, forming will be plastic deformation of the material, machining will be your material removal. So machining is a subtraction type of part. Okay, so this will be the answer will be the third one. Okay, someone else has joined. Okay, someone else has joined. Okay, so answer will be, so casting is a process of melting and shaping material. Forming is working of material to bend and roll material. So there are various forming processes where you bend and shape your material. Machining will be removal of material to smooth the surface. Next question is, consider the following statements and select the correct options. So one or more than one statements can be incorrect. So first statement is, pure metal melts at a single liquidus temperature. Second is, eutectic alloy melts at a single liquidus temperature, and normal alloy melts at a solidus temperature. And the combination for these correct statements is, your options are 1 and 3, 2 and 3, only 1, and 1 and 2 only. So try to figure out which one is the answer. Okay, so I'll be checking what are the answers. 1 and 2. Okay, you're correct. 1 and 2 will be the answer, because your eutectic composition, when it is in eutectic composition, at an exact composition, it acts as pure metal. So it will melt at a single liquidus temperature. And in case of eutectic alloy, if you go beyond that composition, then it will be melting in a range of the temperature. Someone else has joined. Okay. Okay, so 1 and 2 will be the answer. Okay, though for those who have joined late, so I'm going through some sample assignment questions which will be helping you to solve the assignment. So from next time, try to join at the time given, so that I don't have to repeat the questions again. So for this question, there are 3 statements given. So in these you have to tell which statements are correct. So in this case 1 and 2 are correct, because your pure metal and eutectic composition alloy will melt at the single liquidus temperature. So here also you can see at a liquid phase will start to melt, then at a single equilibrium temperature it will start to melt. So your amount of the liquid and solid will be changing throughout this time, but your temperature will be remaining same. Okay, so under equilibrium conditions, eutectic alloys exhibit a definite melting or freezing point. And if a cooling curve is plotted for a eutectic alloy, it will show a horizontal line at the melting or freezing temperature. So pure metal doesn't have different temperatures for liquidus and solidus, and similarly eutectic composition also melt at a single liquidus temperature, and normal alloy melts at a liquidus temperature, and here it is given as solidus temperature, and there will be a range in this case. Okay, in case of normal alloy, when it doesn't specify that it has a eutectic composition or not. Okay, someone has, I think. Okay, someone else has joined. Okay, so these are the statements how these should be. So here it should be either liquidus, or it should specify that it will melt at a range, and at liquidus it will melt completely. So it should either have liquidus or it should have a range specified in third statement to be correct. Next question is carbon, iron and aluminum alloys are. Your options are, okay, someone else has joined. Okay. So next question is cast iron and aluminum alloys are ferrous and non-ferrous metals respectively. Non-ferrous and ferrous metals respectively, both ferrous or both non-ferrous metals. Okay, someone has joined. Okay, so okay, the answer already got revealed. So okay, you can try to understand what is the correct answer yourself as well. So cast iron and aluminum alloy. In case of ferrous, okay, yeah. Do you have any question? Someone has unmuted. Do you have any question? Okay, then I'll continue. Okay, so ferrous metals are the ones which are related to iron, ferrous alloys, okay, which are related to iron, where one of the component will be iron. So in case of cast iron, there will be iron, and also there will be presence of carbon, and in addition to that you can have silicon, manganese, sulfur and other alloying elements as well. In case of aluminum, aluminum doesn't have any ferrous component to it, so it is a non-ferrous metal. Okay, and from these metals also you can try to classify which metal will fall into ferrous category. So out of these, only cast iron, wrought iron, steel, carbon steel, alloy steel, these are the ones that will fall into the category of ferrous. Aluminum, brass, titanium, tin, zinc, copper, lead, all these will be in non-ferrous category. And in case of engineering materials, this is the main classification that you should remember. Okay, someone else has joined. Okay, so in case of metals, there's category of ferrous and non-ferrous, and in case of non-ferrous, all the elements except iron, consisting of iron, will be in non-ferrous category. Non-metals will be in your periodic table there will be metals, semi-metals and non-metals. Okay, so in case of non-metals, your right hand side of the periodic table will be non-metals. So here you will be having hydrogen, helium, nitrogen, oxygen. These are all in gaseous form. Next will be liquid, which will be bromine. Then solids such as carbon. Carbon can be in form of coal, charcoal or diamond, graphite, etc. Phosphorus, sulfur, selenium, iodine, these are some solids. Next up you have ceramics, which are the oxides, mainly oxides, or these can be single components as well, having very high melting temperature. So diamond and graphite are also ceramics. Polymers, polymers will be hydrocarbons. So these can be natural and synthetic both. So wool, silk are natural. Polyethylene, PVC, nylon, bakelite, these are the synthetic ones. Then you have composites, which have wood, concrete, fiberglass, CFRP, which is carbon fiber reinforced plastics, and GFRP is glass fiber reinforced plastics. Okay, so next question is forming process is an example of. Your options are addition of material, subtraction of material, equivalence of material, or removing of material. Okay, so out of these you already know that subtraction of material and removal of material, these are both the almost similar terms, so this can't be the answer. Okay, now you have to find out whether it's addition or equivalence. So type your answer in the chat, or you can unmute yourself and tell what is the answer. Okay, so answer will be, okay, someone else has joined. Okay, so answer will be equivalence of the material. In case of forming and casting, both of these processes, your material will be equal. So how much of material that you are putting in that process, it will be equal in the product. Okay, so it won't change. While in case of for example, in joining, your material will be added. Joining such as welding and soldering. And in case of machining, you'll be losing some material in form of chips. Okay, so in machining you'll be losing some material. Now we can explain this by saying the forming of a material aims to give it a particular shape following a series of specific techniques. So this process makes it possible to reshape a part without adding or removing material in metallurgy. Now manufacturers can carry it out thanks to various methods. Now these are the various methods of forming: rolling, forging, extrusion, wire drawing. So these out of these, rolling will be in this process, workpiece is in the form of slab or plate, and it is compressed between two rotating rolls in the thickness direction, so that the thickness is reduced, and the rotating rolls, they draw the slab into the gap and compresses it, and the final product is in the form of steel. In case of forging, the workpiece is compressed between two dies containing shaped contours, and the die shapes are imparted into the final part. Next is extrusion. In this, so here your workpiece is compressed and pushed through this die opening, and so it takes the shape of this opening. Okay, and next is wire or rod drawing. So it is similar to extrusion, but at the hole will be this hole will be circular and will be smaller in size. 10th question is, a manufacturing approach which aims to reduce waste is known as. Your options are flexible manufacturing, lean manufacturing, just-in-time manufacturing, and agile manufacturing. So you should know definition of these all these four, and one more, bulk processing. So these five you should know already. What are the definitions? Sir told it in, I think, 5th chapter. So what will be the answer? Type in chat or unmute yourself and tell what is the answer. Okay, so answer will be lean manufacturing. Okay, so I'll be telling what are the definitions of all these four, so that if you get similar question related to all these four, you can answer. So in case of flexible manufacturing, it has a workflow methodology aimed at reducing flow times within production system. Second is lean manufacturing. Lean, as the name suggests, it is the methodology that focuses on minimizing waste within manufacturing systems while simultaneously maximizing productivity. Just-in-time manufacturing, it is a production model in which items are created to meet demand, not created in surplus or in advance of need. Agile manufacturing will be a way to create and produce things in a manner that is more flexible and adaptable than traditional methods. So these were the questions. Now we'll be going through lecture notes. So should I go through the questions once more for those who joined late? Please type yes in chat if you want me to go through the questions one more for those who joined late. Okay, then I'll start with the lecture notes. Akshay, which slide do you want me to show, like 10th question or next, to move to the lecture notes? Please type in the chat. Slide 10, question 10. Okay, so you can take a screenshot if you want. Okay, now we'll be moving to the lecture notes. Okay, so first lecture is understanding manufacturing. So firstly, your word manufacturing. So most of the notes you need to study thoroughly, because any question can be related to this. So even from the definition and how the word is formed. Okay, so manufacturing is formed with two separate words, manu and factors. Okay, so manus means in Latin hand, and factors meaning made. So it is made with the hand. So manufacturing is made with these two words. Okay, and manufacturing has two definitions. Technologically, your definition is that physically and chemical processes used to alter size, shape and properties of material which are suitable for service use. Economical definition will be, in this case, you add value. After manufacturing, you will be adding some value to the material. Okay, so material before your manufacturing, it will be having lesser value in market compared to after you form it. Okay, so a step to convert probe. Yeah, do you have any question? Okay, I'll be, note slide is not visible. Okay, is it visible now? Let me know if it is visible. Need and manufacturing.
Now visible.
Now visible, right? Okay. Okay, so economically you are taking a step to convert your raw material. So for example, you have some plastic sheets, right? So that has lesser value in market compared to your bottle, right? After you have converted it to bottle in after manufacturing. So you are converting it into useful product of high value. Next, what is the need of manufacturing? So these are the three reasons why we need manufacturing. Firstly, to create goods for human being to support living and improve standard of life, right? So why you require your mobile phone? You want to improve standard of life. Next, producing more goods using less resource is the target to cater needs of public in general. So if you are wasting a lot of material in making all the products, then it will lead to reduction in the your efficiency of the manufacturing process. So you will have to move to another manufacturing process. So productivity is of the prime importance and is achieved by reducing wastage in the form of scrap and defective products. Okay, so it also should not produce various defective products. So for example, when you choose casting, there is a lot of castings will be in such manner that it will have a lot of porosity, that it won't be of any use. So you should use a manufacturing technique which is appropriate for that particular product. Someone else has joined. Okay, I'll admit. Okay. So there should not be much scrap produced either. So in form of chips, when you do machining, there is formation of chips, which increases your material wastage. Okay, for those who joined late, I'm going through lecture notes so that you can understand how to solve your assignment of this week. Next, resources for manufacturing. So in manufacturing, for producing goods, used are the resources in the form of natural resources and machine tools. So in case of natural resources, you require air, water, animal, wheat, mineral, etc., which you are getting directly from nature. Machine tools are man-made. Okay, so these are such as plants, machines. Plants are not those plants that grow on ground, but these are the plants in which you manufacture machines. Machines, tools, robots, automation, these are the things that are machine tools. And the creation of goods for human being, this is kind of a equation that you can remember. So you require natural resources, main power, you require a man to run those machines, and you also require some automation or some machine tools to manufacture these goods. Now, types of industries. So there are 3 types of industry. I think you have also learned it in your primary education classes as well. So you are taught that there are 3 types of industries: primary industries, secondary industries, and tertiary industries. So manufacturing industries are organizations which produce or supply goods and services. In case of primary industry, you will be getting these directly through nature. Okay, so in case of agriculture, you are growing crops, so this is you getting directly from nature. Fishing also you are getting from rivers and ocean. Okay, someone else has joined. Okay, so those who have joined late, we are going through lecture notes. So in case of primary industries, you will be getting these directly from nature. Agriculture, fishing, mining. Mines are also made from nature, right? So you are getting your minerals from mining. Next up is secondary industries. It uses output of primary industry. For example, if you through agriculture you got wheat, then you will be converting it into making bread. So a bread factory will be your secondary type of industry. In case of tertiary industry, these are mainly services. For example, banking, medicals, hotels, IT sectors, these all are tertiary industries which don't have direct relation to nature. Direct or indirect relation. Next will be scope of manufacturing processes. So science and technology of manufacturing a product effectively, efficiently, economically and environment friendly through use of existing process. We can either use existing process, we can either use improve the existing process, improve the existing machine and materials. We can select the input material, machine and environment in such a manner that we try to improve the efficiency. Yeah. Are the slides not visible?
Ma'am, at the time of teaching you, that slide is not visible. It is late.
It is delayed.
Yes, ma'am.
Okay, now is it visible? Scope of manufacturing processes.
Yes, ma'am.
Okay. Okay, so I'll try to slow down so that the slides are visible. So next up, you can fourth you can also develop a newer processes, systems, materials and techniques, so that you can improve the either efficiency, you can either make it economical, you can either improve its effect on environment. Okay, so we are also trying to move our batteries and all, the circuitry board, we are trying to use less of lead and other toxic metals so that it doesn't cause any environmental toxicity. Now, need of improving and development manufacturing processes. I hope that this slide is visible. So in this case, sometimes we need to improve the existing manufacturing processes. So it is to deal with the requirement of increasing productivity and quality and economy to cope with global competitiveness and increasing miniaturization. So we are trying to miniaturize all the devices. For example, we are trying to make all of our devices more and more compact. We want smaller iPads, right? So smaller mobile phones, smaller laptops, and we want high output as well. So for that you require improvement in all manufacturing processes as well, in materials as well. So precision of parts for medical and electronic industries. In medical industry as well, you require increased miniaturization. So for example, you try try to make your medical equipments or some medication delivery, drug delivery vehicles that are being formed are very miniaturized in these days. Someone has joined. Now, processing of newer and exotic material for advanced application in aerospace and nuclear industry. So there are a lot of requirement for improvement in these sectors. Now, next slide is fundamental approaches of manufacturing. Okay, so in this case, in this chapter, first off, there is purpose of manufacturing. Okay, so first it is to making usable products for human beings having required attributes. So you require particular size and shape of product, you require particular surface finish. So for this we can take example of you can take example of your charger of mobile, right? So for that it should fit into your 3 point or 2 point plug, right? So for that it should have a particular size, it should have a particular shape, it should have good surface finish, it shouldn't have uh, some edges which can cut your hand, right? And it should have good control tolerances, it should have good properties so that it can withstand some heavy loads or anything, and it should have characteristics for prolonged life. So that's why its material will be chosen according to that. Now fundamental, now I'm on slide 21, fundamental approaches of manufacturing. So in this case, you firstly you have primary shaping. So in this case you have casting, forming and powder metallurgy. So in these case you will be directly shaping your materials. In case of joining, next is joining. So you will be having brazing, soldering and welding. Here you will be having some rods or some different sheets that you can solder or braze. You can join those. You want to be making a material, you should already have material. So these are secondary processes. Joining. Primary is because you don't require pre-existing shape. So here you should have some metal, then you will be pouring it, you will be heating it and pouring and giving a shape. So this is primary shaping. Next you have material removal processes. In this case you will be having metal cutting or some unconventional machining. So in case of unconventional, you can have laser cutting, you can have other forms, such as you can even use electron beam to cut your materials. Next you have regenerative processes. So in we'll also study about these in detail. This is layer by layer approach. It is also known as additive manufacturing. Next you have super finishing processes. So as I we had a question also on lapping, honing and polishing. These are some of the processes. Next you have improving properties. So for improving properties of final product, you can use heat treatment, coating or case hardening. So we'll study about these in upcoming chapters. Next we have regenerative processes. So it is the production of solid products using layer by layer approach of raw material. So this is the process I am assuming that most of you will be studying for the first time, compared to casting and welding, other processes which are quite well known. So in this case you have solid products which you will be forming using layer by layer approach. So in this case you can have liquid form as well, powder form as well, sheet form and wire form. In case of liquid you will use stereolithography. In powder case you will be having selective sintering. So in powder metallurgy, when you will be studying further, you will study about this. In case of sheet, you can layer by layer form sheets, and you can organize these sheets in form of laminated objects. If you if you rearrange wires in layer by layer, then you will be getting some fused deposition. Now this process uses CAD, CAM, which is computer assisted designing, computer assisted manufacturing and rapid prototyping systems. Next is casting. So this is very quite well known process. In this case you have taken this scrap in this okay, I'll use pointer. Okay, so this is scrap that you have put in your crucible. Okay, this is the crucible which is made of some ceramic. So you will be putting your scraps, this will be melted after heating, then you will be pouring this molten metal in these molds. So these molds can be open as well, and it can be formed in this form as well. So after these complex shapes, so after you will be pouring it, then you will leave it for solidification. So this is the mold cavities, this is also mold cavity, then melting process will be this one, and then you will be pouring and letting it solidify. Then you will be removing your mold from your product, and then after cleaning, finishing and inspection, you will be seeing whether how your casting has formed your product. Yeah.
Ma'am, slides are paused.
Slide, its casting is not showing. Is casting not
It
showing?
is not showing.
Okay,
It is
then
not showing. Now it is visible.
Okay. Okay, now it's visible, right? I'll show in this mode only, I think.
Yes.
This is better. Okay, so in casting, you have, I'll repeat this part. You have this scrap. This is your scrap that you are melting in this crucible, which is made of ceramic. Then you are after melting, you are pouring it. There are other methods of pouring as well. You can pour from top, or you can pour from bottom as well. So after pouring, you leave it for solidification after you remove your product from the mold. Okay, then finally after casting, what happens, your surface finish won't be very much good, so you require finishing as well. First you will be cleaning sand from your casting, then you will be finishing, then you will inspect it for any defects that are left. Now next is forming. Now in this case, this is a blank sheet. You can give by bending, you'll be giving it a shape of this type of some uh, final product. Now in this case, you'll be requiring some mechanical properties that you should know about. Next up we have joining. Next up we have joining. So in this case, you have a positive, or in case of joining, you are adding various metals, right? So in between you are adding adhesive as well. In this case you are adding some solder, through solder as well you are adding some metal. So that's why it is known as addition type of process. And in case of machining, you will be calling that subtraction type of process. So in this case, okay, so in this case, a positive process which is used for assembling different members to get desired configuration. And we can join, can be temporary or permanent in the nature, and this can be produced by gas welding, braze weld, adhesive joining. Adhesive can be the glues that you use, such as Fevikwik and all. It can have mechanical joints. Mechanical joint will be nut and bolt. It can have fusion welding, it can have spot welding, and it can have soldering. We'll study about these in detail, but for now you won't be having these detailed questions in this assignment. In detail we'll study later. Next up you have machining. So in case of machining, it is a subtractive type of process which is used to get desired shape, size and finish by removing surplus material in the form of chips. So for example, if you have got some 5 mm diameter rod. Now you want to reduce its size to 4.5 mm diameter. So for that you will be using lathe machine, and for that you will be doing machining. Now your excess material will be removed in form of chips. Okay, so now you, okay, anything, okay.
For this, we can use turning process.
Yeah, you can use different type of processes, turning, tapering and all. Tapering when you'll be providing some type of angle. So all those processes are used you by using some cutting tool and some machines such as lathe and other machines. Now this is a subtractive process which is used to get desired shape, size and finish by removing surplus material in the form of chips by a cutting tool. Now your cutting tool should always have higher hardness compared to your material so that it doesn't break, and by providing suitable relative motion between the workpiece and cutting tool. Now your cutting tool has the work of removing excess material. You can use drilling, all these. In case of drilling also, you'll be getting some chips, small chips formation. So uh, all these processes, these are part of machining. Next, you have manufacturing process specific advantages and limitations. So for all these processes, these 5 processes that we have studied, casting, forming, machining, joining and regenerative processes, will go through their advantages and disadvantages. So in case of casting, you have shortest route to get complex shapes. So as I told in first or second question, right, you had crankcase, so that is very complex part of the uh, your engine. Okay, so for that, for getting complex shapes, you use casting. So even with internal features like through and blind holes, so these holes, these can also be made easily in case of casting. In case of casting, you don't require mechanical properties. These don't limit the capability of process, and it is compatible for custom, batch and mass production, and it is compatible for very few millimeter or gram size to meter per ton size of castings, and it has a common method for composite materials. So for example, there are various casting methods in which you can form these composites as well. So in case of composites, what happens that you have a reinforcement particles or reinforcement rods which will be suspended in your matrix. So your matrix will be, for example, it can be metal, it can be polymer or it can be ceramic, and in between those you'll be having some reinforcements. So compo casting is one of the examples which is used, and I think we'll study about that later. In case of disadvantages, so casting has moderate surface finishing and tolerances. So after you get the product from casting, you'll always require some finishing processes to get surface um, good surface finishing, and there are tolerances. So tolerance are, for example, when you will be casting, your material will be, in case of due to gravity and all those and shrinkage that occurs in some metals, you'll be having some tolerances. Someone else has joined. Okay, so we are going through lecture notes for those who have joined late. So it has possibility of external or internal defects. So internal defects can be formation of porosity or shrinkage, all those are internal defects. Now it has also tendency of interaction with ambient air. So it can, for some materials such as magnesium, these can react with oxygen that is in air. So you need to provide vacuum for certain elements, and casting is often needs machining, processing and heat treatment, and it is difficult. Okay, as I told earlier, you always require machining or some type of processing, and heat treatment you also require because there is always some heterogeneity that is generated in castings. So after you will be casting your material, your if you have different, if you have formed an alloy, then metals will segregate at particular depending on the heat zones that will be there. So you always require some heat treatment as well. And casting is difficult for high melting temperature metals. So why it is difficult for high melting temperatures, can anyone tell? Can anyone take a guess like why it is difficult? For example, tungsten has very high melting temperature. So why is it hard to melt tungsten and make it cast it into something? Okay, so the answer will be because for that, yeah, yeah, take a guess. Anyone?
which
Why it is hard
which
to, why,
melt the melt the matter
you're not audible, Akash.
inside.
You're not audible. Can you type the answer if you're trying to answer the question? Okay, so okay, I'll go ahead. So why it is difficult? Because for that you will require crucibles to hold that material, which should have higher temperature than high melting temperature than that metal. Okay, so you'll require some ceramic which should have higher melting temperature than your tungsten melting temperature, because you'll be handling liquid tungsten. So that is for you'll be left with very few choices in ceramics that will be having higher melting temperature than that, which can handle this high temperature. Okay, so that's why it becomes very tricky when you'll be having some metals which have high melting temperature and you'll be trying to cast those. So mostly those metals are made by using powder metallurgy, because in case of powder metallurgy you require sintering. Okay, and sintering requires temperature which are lower than melting temperature. Now it also has chemically and metallurgically heterogeneity. So as I told earlier, why we require heat treatment. So when you'll be cooling, when you'll be heating and cooling your material, someone has joined. Okay, so in case of your if your material has different type of elements, for example you have magnesium and copper in your alloy, then your low melting temperature metal, and which one will be, when you'll be cooling, one will be solidifying earlier compared to the other, right? So that's why there will be heterogeneity, there will be formation of dendrites, there will be all type of defects that will be arising because of this type of casting. Next process is forming. So in case of forming, it can provide you high production rate, so it can be easily automated, so that's why you can obtain high production rates. And it has improved mechanical properties, it has reduced internal defects. So in case of forming, you'll be bending your material, right? You'll be either bending, you'll be compressing your material, which will lead formation of some dislocations in your material. Now these dislocations interact with each other and provide some strength to the material. That's why these have high improved mechanical properties. And in case of these have reduced internal defects compared to other processes. For example, in case of casting, you will be having porosity and all other defects, but in this case you won't be having these defects. Compressive residual stresses. So in case of, for example, forging, you're beating your material at high force, so it will be having compressive stresses in your material, which are all mostly good for your fatigue strength. And it has easy automation. So as I told earlier, forming is easy to automate, so you can use robots and all automatic machines. It has close control over the properties, so you can easily predict what will be the property after you are, for example, you're using extrusion or other processes. Next is high strength to weight ratio. Your material will be having higher strength to weight ratio compared to casting and machining, because in case of machining and casting you will be having lower of amount of these dislocations. Now these are the your disadvantages. Now your material will be anisotropic. So after forming, as you saw earlier, right? Okay, in this slide, right? So here after extrusion you will be seeing that your material flow won't be even in this part, and in this part as well your material flow won't be even, so dislocation, distribution, all those will be different in different parts of your material in this as well. So your material won't be isotropic, your material will having a flow as well of grains and all, so this will be having anisotropic properties. Okay, and now it is limited to simple shapes. In case of forming you can make simple shapes only, so in case of extrusion as well you can understand that you can have a similar type of cross section, and in wires and rods also you can have a single cross section, you can't vary that. It needs machining to achieve required finish and tolerances, so you will require some machining after, because some of the forming operations are done at the higher temperatures, so your finishing of the product won't be nice. Next is difficult control of process parameters. So process parameters won't be controlled that effectively as you can control in other processes such as regenerative processes. Okay, someone else has joined. Admit. Okay, now for those who joined late we are going through some lecture notes. Okay, next is mechanical properties in case of forming, such as yield strength and ductility affect success of process. For example, if your material has very high yield strength, you won't be able to easily deform that material. So if your material is very brittle, you won't be able to form it into shapes that are required for a product. So for forming you need to select mechanical properties as well, which wasn't in case of casting. Next is machining. Now in case of machining you will be getting very good surface finishing. So as I think some of you might have worked on lathe machine or some machines as well, so after that you can see that the surface will be very shiny, it will be having good surface finish, and it will be having close control over dimensions. So after casting as well, you for providing close control to the dimensions you use machining, and you can form complex shapes as well using machining. You can have capability to produce high aspect ratio features. For example, you can make a hollow pipe as well using machining compared to some other uh, processes that we studied earlier. And variety of surfaces, flat, curved, and mix of various profiles can be made. So compared to, for example, in extrusion you can't easily make curved type of surfaces, while in case of machining you can easily obtain those. These are the disadvantages. So in case of machining you'll be losing a lot of metal worth in form of chips, and there is low production rate. Okay, and production rate, why it's low? Because you'll be requiring some worker that will be working on the lathe machine, that will be controlling your, okay, someone else has joined, so you require skilled workers as well. So it will it is not that easy to automate your this type of processing, so this will be having low production rate, and there is high initial investment on machine tools. So for example, the machines such as CNC or your lathe machine, these all require high initial cost, and also it is hard metals are difficult to cut. So if your material has very high hardness, then you will be requiring cutting tools which have very much high hardness, so those tools will be very expensive and very hard to get. Next is welding and related processes. Now in this case, these welding, it helps to develop large structures using simple shapes. For example, you have a lot of roads, then you can connect those using welding, and you can create a very complex shape, which you can't create a very hollow and very complex shape, which you can't form using other processes that we have studied earlier. And to develop components which otherwise cannot be made using other manufacturing processes. Joining of similar and dissimilar metals is also possible in this case, which is not possible in case of, for example, casting and forming. And these joint, it can be stronger than base metal. For example, uh, when you join two steel parts, then the joint that you are using, that can be even stronger than the base metal. Next is joining in liquid solid and liquid solid variants as per needs. So in case of welding, this can be in solid state as well. So you'll be studying later that in case of, for example, spot welding and other type of weldings, you can have solid type of joints as well. So there you don't require any liquid metal to join the two parts that are broken. Next is, these are the disadvantages of your welding process. So as you have, if you have studied about welding, then you already know that welding has a problem of heat affected zone. In this part, what happens, for example, in case of steel, your in that part formation of martensite will occur. So martensite is very hard type of structure, so it will have low ductility, low toughness. So if even it has very small notch, so it will have very low notch sensitivity, and it will have heterogeneity in terms of mechanical and metallurgical properties. So your material, so as you know, if there is martensite has formed in middle part and other part will be having pearlite, then there will be heterogeneity in terms of metallurgical and both mechanical, because hardness will be different. Okay, someone wants to join. Okay, someone has joined. Okay, so next is, it will also have, so if there is in middle part there is martensite and other parts has pearlite, then there will be hardness difference as well. So hardness will be different in different parts, and there will be, because of that, residual stress will be also present because of formation of dislocations. Now there is also increased corrosion tendency. Now in case of stainless steels, there will be in heat affected zone and other places there can be formation of chromium carbide, which reduces formation of chromium oxide, which provides corrosion resistance. So that's why it increases corrosion tendency. Next is also color mismatch possibility, and also thick and thin sections need extra care. So if you are joining some thin joints or thick joints, then there is needs to be extra care, and there is it is needs secondary processing. So your initial joint, so whatever you are joining, those rods or those plates, those need to be formed using some primary processing such as casting, powder metallurgy, or other processes. Next is low reliability. So your joint, in some cases such as brazing and soldering, you have very less reliability with that joint. Notch sensitivity I covered already. Next is regenerative process. Now regenerative process, as I told earlier, it is additive manufacturing. So in this case you'll be having some solid or liquid, semi-solid, liquid, or some various parts, and you'll be forming your material layer by layer. Okay, and these can be used in making some complex shapes, and this also has some ease of manufacturing, and you can form your shapes in wide variety. And also this process is very much automated, so it has very quick response time. And this process also has ability to deal with dynamic demand for variety of products. For example, some of the composites that we require in these days, those are can be formed by this technique only. So there is a lot of flexibility with whatever the requirement is there or whatever demand is there. Now these are the limits of this process. First is, it is limited to only plastic and polymers. So for metals it is not that much feasible. And ribbed surface, your surface won't be smooth. After formation of this process, your surface won't be smooth, and it has very high initial cost. So your setup that you will be requiring for this regenerative process, additive manufacturing, it has very high initial investment. Next is low volume production. So your production, so whatever you are forming, it will be in very low volumes compared to what you get in case of casting and in case of your powder metallurgy. Next is, it has high cost. So cost we already covered, so you require a lot of investment for initial as well, for material as well. Now next chapter is materials and manufacturing processes. Now while we are talking about materials, so now to know their suitability for intended performance in a given situation. For example, if you have selected your manufacturing process and product, then you need to select your material as well. What material you will be choosing? For example, a table that you are forming, you can choose wood, you can choose plastic, you can choose metal. What you will choose, that will depend on its performance, like after forming, how it will perform, how long it will last, and to get the idea about what changes are needed otherwise. Okay, now if you have formed and you have tried to get what is the performance, then you can change those material as well. And next is, if you have selected your material, then some certain manufacturing processes are also limited. For example, if you have chosen metal, then you can only go for certain manufacturing processes, you can go for regenerative process, so that will be limited as well. So give the desired size and shape, these all factors will decide what manufacturing process will be used. Now for example, this is a car. Now in this, various matters that I used, so you can also, after this lecture, you will go around and you find out any product and you try to find as much type of materials that are there as possible. For example, in this car, your steering wheel, so even your steering wheel is made up of plastic, rubber, metal, all sort of materials are used in forming even that single component. Now in this battery that is used, it consists lead, and this wheels, these are used either steels or aluminum depending on what is the value of this car. This body of the car, it can be made of either steel or reinforced plastic body. Your engine can be either made of cast iron or aluminum. Your plug is always made of ceramics. Your copper wiring is required for some cooling, and plastic windshield, washer fluid tank, steel frame, rubber tires, stainless steel or aluminum trim, your tungsten filament for light and bulbs, your plastic tail of light lenses, glass windows. So how many materials that you have used even in single car. So even a single pen, it consists a lot of materials as well: plastic, metal, ink, which is your uh, organic compound. So a lot of things that you use, you have to try to decipher like how many things you are using, how many materials that are used in forming that, how many working components are there. Next is material properties of importance for manufacturing. Now these are the various properties that you have to list in order to select a product and after selecting a material. So for that material, its physical properties such as thermal conductivity, thermal expansion coefficient, melting point, solidification, solidification temperature range for alloy. These all things you should consider for selecting. Someone has joined. Okay, and in case of chemical properties, you, for example, if you are choosing nickel is a metal, so it has chemical affinity or not. So it should have corrosion resistance, it should have oxidation resistance. So some metals, they form a layer of oxide, and so there is no further oxidation or corrosion. So that's how you select a metal, or that's how you choose some materials. In case of mechanical properties, you consider hardness, strength, ductility, creep, fatigue, fracture resistance. It should not fracture very easily, it should not undergo fatigue. Next is dimensional. So dimensional, these are parameters. So how straight your material is, how flat your material is, how round your material will be, how its surface roughness will be your product, and how much length you require. These are the parameters. Next is casting. Now in case of casting, which properties that you need to take into consideration. So initially we went through the questions, then one of the question was that in which of the processes you don't require mechanical properties. So in casting you don't require mechanical property because you are melting your material, it will be in liquid form. So after that you also require solidification temperature range. So if your material is alloy, then it will be having a range. So you need to consider if the range is very high, if range is very small. For example, if you want to form a very complex uh, casting, then you should have very small range of the solidification, otherwise your material won't be solidifying in very complex shape. Now solubility in liquid and solid state. For example, copper and bismuth or some other elements that you are taking, if it is not soluble in solid state, then it won't be a good product. Reactivity of metal with gases. For example, your magnesium can react with oxygen or other gases, so then you need to take that into consideration. So you need to use vacuum for that casting. Thermal expansion coefficient, even at higher temperature, when it is in solid state it can expand. Alloying segregation tendency, so your alloying elements, they can segregate. Next process is forming. So now this is the stress strain curve that you must be, I think, familiar with. Now this is the elastic part and this is the plastic part. In plastic part it will start after yield strength, so forming will always occur in plastic part, right? So you are changing the shape of material, so for that you need to go beyond yield strength. So your materials yield strength will matter, your materials ductility will matter. If it is very brittle, you won't be able to form your material very easily. Okay, and it should have work hardenability, it should have thermal softening, whether it has how much thermal softening, which is not very good either. Thermal expansion coefficient, this will also matter in case of forming, because in case of forming sometimes you use higher temperatures as well. Strengthening mechanism of metal, which strengthening mechanism is used, that will also come into play. Machining requires these properties, like these properties you need to consider. So in case of machining, I told you that machining tool should have higher hardness than the product, right? So hardness you need to know of the material, you need to know ductility of material, you need to know the strength of material, you need to consider thermal conductivity, because if your chips that are forming, if those are generating and those are having very high heat, then it might be problematic sometimes. So it should have good thermal conductivity, and most of your metals have good thermal conductivity. Interaction of work metal with tool material, right? So your tool material, how it reacts with work metal, that also need to like looked into, like it should not get welded with each other. Like if they have affinity to each other, they might get welded, and then you can't continue your machining. Next is welding. Now in case of welding, some of the places you, for example in case of steel, someone has joined. Okay, so after, okay, so in case of welding, if you are joining two steel plates, right, in that case you have option. Okay, someone has joined. Okay, for example, if you are trying to join two steel plates, you can choose steel as a joining material as well. Now in that case, what is the melting point of your joining material, filler material, that will also come into play. What is the solidification temperature range of your material, what is solubility in liquid and solid state, that will also come into play. Reactivity of metal with gases, now the gases that are surrounding your material, that also play role, so those might act with the filler metal or flux and become problematic sometimes. So you need to understand what is the reactivity of metal with gases. So you can't use metal which is very reactive. Next is thermal expansion coefficient. So at higher temperature, if your one of the sheet is expanding more compared to other, then it might be problematic. Alloying segregation tendency. So in heat affected zone, this might be a problem if your alloying elements are segregating. Yield strength and ductility, this also you need to consider, because there might be formation of martensite or some other type of microstructures, which might lead to which might weaken your final product. Next is yeah, do you have any question? Okay, now next is applicability of different manufacturing processes to different types of engineering materials. Now we have already studied like various processes which material can be used and which can't be. Now metals can be used in most of these processes except in case of primary forming processes in case of advanced. Other than those, metals and alloys can be used in most of the processes, and polymers can also be used in most of the processes except in case of deforming processes, because in case of this forming processes you require dislocation motion, and polymers don't provide that. And in ceramics also you don't have that much dislocation interaction, that's why you don't use deformation processes in case of ceramics and composites. Now next is application range of manufacturing processes according to the melting temperature of material and batch size. Now if you keep on moving further at higher temperatures, you can see that at very low temperature, at 10 degrees Celsius to 100 degrees Celsius, you can use polymers, and after that 10 to 1000 degrees Celsius you have some metals that you can use, for example tungsten and some other metals which are heavy metals you can use at higher temperatures. In case of ceramics you can use at very higher temperatures. And as production volume you can see with increase in size, these are the processes that you can use. So in this case your regenerative process, we already studied that it has it uses polymers, that's why it is falling in this category. And metals and ceramics, there's are this material removal and these processes are used. Now based on that this graph is plotted. Next is last chapter is classification of manufacturing processes. Now why we required to classify these processes? First, what is the need? Now these are the needs. Firstly, if you group various things, now it becomes easier to understand. For example, if you have grouped all the metals together, then you will study how metals work, then it will become very easy, like understanding dislocations and their movement, all these becomes very easy. If you'll be studying it for different metals, then it will become very tricky. Now to group various manufacturing processes based on fundamental similarity in their nature and to have better understanding of each process. So to group various manufacturing processes based on fundamental similarity. So if it is similar, then we'll group them together. And to have better understanding and to make communication easier by having just one name of each process. For example, forming process, there is a lot of names that you have already studied: metal working, forming process, deforming process. So all those should be easier to communicate and to organize information about manufacturing in better way, and to help naming new or hybrid processes. So if some process falls in between two processes, then it will become easier to name them. Now the basis of classification. So classification of manufacturing processes depends on its purpose. So these are various bases that you will be classifying those. And first is interaction during manufacturing. Second is materials that are used, if it uses metals or polymers. Extent of automation, it can be manual, semi-automatic or completely automated. Treatment of metal, approach, user, production strategy, system organization or newer approaches. Now first is scientific aspects. Now based on analysis of interaction between the bases, disciplines and manufacturing applications. Now grouping of processes into chemical industry. Now these all will deal with chemicals. So for example, some of your medicines that you use, those will fall into chemical industry. Some chemicals that you use, those will fall into this chemical industry. Bioengineering or biotechnology, that will deal with your biology. Nanotechnology, now the material nano is 10 to the power minus 9 meter. Okay, so on that scale level, right, when you will be dealing with that scale level for metals or some other polymers, then you will be calling it nanotechnology. Next is electronics. In this case you will be talking about all the electronic devices. And in case of construction, so this is a construction industry. Next is materials. Now based on processed materials, now processing of metallic or polymers. Now material based on, if you are talking about any metals, then you will classify all those industries into metallics and polymers, then ceramics, glasses, composites, biomaterials. Now for material engineers, they will use these type of classifications. Now in one of the questions I also told this classification. Now these are various metals that we deal with in day to day life, and these are the engineering materials. Now this is the classification. Firstly you have metals. So on the left hand side of your periodic table you see metals, right, which have tendency to give electrons. And so it can be ferrous or non-ferrous. Ferrous will be having iron in it. So iron, steel, cast iron, all these will be ferrous. In case of non-ferrous, all other elements will fall into non-ferrous. These non-ferrous can also be classified into heavy metals, light metals, or other type of precious metals. In case of non-metals, these will be on the right hand side of your periodic table. So these can be gases such as hydrogen, helium, nitrogen, oxygen, and these can be liquid as well, such as bromine. These can be solids as well, carbon, phosphorus, sulfur, selenium, iodine. And ceramics will be having very high melting temperatures. So these are based on these properties, and these are used as a refractories. So alumina, silica, silicon carbide, diamond, graphite, all these are ceramics. These are mainly nitrides, carbides or oxides as well. Next is polymers. Now these are hydrocarbons. These are made with chains, various chains, which can be natural such as wool, silk, cotton, etc. And these can be synthetic as well, such as polyethylene, PVC, nylon, bakelite, etc. Next you have composites as well. In this case you will be having wood, concrete, fiberglass, CFRP and GFRP, which is glass fiber reinforced plastics. Next is based on automation. So based on extent of human tool product interaction, one can distinguish such as manually operated. Now if someone is making, for example, someone is making chapati or something like that, then that will be manually operated, which doesn't necessarily will be having any automated part in it. If for example making bread in a factory, then it can be semi or fully automated as well. So semi and fully automated systems with fixed or variable routing. Next is treatment of metal. Now based on whether we treat the workpiece by addition of material, for example in case of joining we always use filler metal, so there will be always addition of material. In case of subtraction, we'll be cutting material from in between, then there will be some material lost from that part, so there will be removal or waste of material. So machining will be in subtraction. Next is equivalence of material, where material won't be lost and complete material will be used. So your powder metallurgy, casting and forming, these will fall in equivalence of material. Next is approach of processing. Now based on the used techniques, processes based on fluidity and solidification of materials, such as casting of white iron in sand molds, processes based on plastic flow in solid state and accompanying elastic reactions, example forging, processes based on joining of solid components, arc welding and other type of weldings, processes based on cutting such as drilling, turning, curling, all those will be in this category. Processes which are based on altering solid microstructure, these will be heat treatments such as normalizing, tempering, etc. Combined processes, where you will be using hybrid techniques, combine the above categories such as sintering. In case of sintering, you heat your metal as well, and you will be compressing, sometimes compressing your material as well. So this will be hybrid technique. Next is types of manufactured products. Now based on user, consumer good, cars and pens, these are the consumer goods. Next can be capital goods, which are further used to produce goods and services. Based on production strategy, you can have hard products and soft products. Now system organization with an emphasis on the final product. Now this can be discrete manufacturing. In this case, your production of toys, computers and cars, it will occur in discrete manufacturing, and there are a number of separate operations is involved, independent in a sense that these operations can be separated arbitrarily in time and space. So you don't need to continue or follow a particular flow to make a car. You can make a wheel earlier, you can paint the body earlier, you can join. So in that toy car or something like that, it doesn't need to be continuous. In case of continuous process or continuous manufacturing, your production of bread, paper or steel rolling, this will follow a particular flow. So it will be mostly automated and will follow a particular flow. Next is newer approaches. So based on some organizational and logistic aspects. Now these are the terms that I told you. You should remember these definitions. So lean manufacturer, which will be reducing the waste. Flexible manufacturing, which will use CNC connected systems. Just in time, also known as JIT manufacturing. In this case, you will be having inventory strategy. So next is agile manufacturing, which deals with changing market. Next is bulk processes, which deals with mass production. Now these are the definitions that I think will be easier to learn. So I told you in one of the questions as well, and I'll repeat it because some of your questions are based on these. So first is flexible manufacturing, which follows a workflow methodology aimed at reducing flow times within production system. So you'll be following a flow and it will reduce time. Next is lean manufacturing, a methodology that focuses on minimizing waste within manufacturing systems while simultaneously maximizing productivity. So you are trying to produce something in shorter time span and you are reducing waste as well. Just in time manufacturing will be a production model in which items are created to meet demand. So you want to be creating something in surplus or in advance of need. Agile manufacturing is a way to create and produce things in a manner that is more flexible and adaptable than traditional methods. Next is bulk processes, which is based on mass production. Now I'll be revising the questions once more for those who joined late. Okay, so if you have any query, you can ask. If you have any query related to today's lecture, you can ask. I'll continue with the questions. So first question was, the automobile component like crankcase is manufactured by. Your options were casting, welding, forming, and all of these. So answer was casting. So for better strength and fatigue properties, crankcase of automobile is made of casting. And due to the oil and cooling channels required for cooling and lubrication purposes, the crankcase is the most complex cast part in a combustion engine. And cavity-free casting can only be achieved through the use of sophisticated casting technology and precise compliance with pouring and cooling times. Next question is, the best surface finish and close control over the tolerance of the casted components can be achieved by. Your options are machining, lapping. I'll go on full screen mode. Okay. Okay, so firstly, second question is, best surface finish and close control over the tolerance of the casted components can be achieved by machining, lapping, shaping, and milling. Answer will be lapping. So lapping is machining process in which two surfaces are rubbed together with an abrasive between them by hand movement or using a machine. Lapping often follows other subtractive processes with more aggressive material removal as a first step, such as milling and grinding. Next question is, powder metallurgy involves shaping and sizing of raw materials to achieve a specific shape and dimensions, which are used in form of solid, liquid, powder, and all of these. So your answer was powder. So someone has either joined. Okay, PPT is not visible. Now is it visible? Now is it visible? Right? So it was visible in this manner. So the powder metallurgy processes consists of mixing elements or alloy powder, compacting the mixture in a die, and then sintering or heating the resultant shape in a controlled atmosphere. Okay, I haven't shared. Okay, apologies. Now it should be visible. Okay, so I'm going through questions again. So you can take a screenshot if you want. So first question I already repeated. Second question I was repeating but it wasn't shared. So in this case the answer was lapping. So you can take a screenshot. Already? Yeah, I told it in detail. Next question is powder metallurgy involves shaping and sizing of raw materials to achieve a specific shape and dimensions which are used in the form of solid, liquid or powder. So answer will be powder. So in case of powder metallurgy, you first form powder of various elements, you mix those, you put those in die, then you pressurize and you provide some heat, and then you get the resultant shape. Okay. So powder metallurgy is a highly developed method of manufacturing ferrous and non-ferrous materials, and it is chipless working process. Next is the process in which mechanical properties don't limit the capability of the process. Answers are either machining, forming, casting or all of these. So answer will be casting. So in case of casting, it is done at melting point where the material is not solid. So mechanical properties don't play a role in casting. And the mechanical properties are important in machining and mechanical working processes because they require bending or movement of dislocations. Fifth question is, in the casting process, the material is heated above the, your options are recrystallization temperature, ambient temperature, melting point temperature, lower critical point temperature. So answer will be melting point. So in case of casting, you will be melting your material, then you will be pouring it into die of your desired shape. It will be either die or some mold. So casting is done. And metal casting is the process of making objects by pouring molten metal into an empty shaped space. Next question was, match the following. So in this case, you have to match casting, forming, machining with the material removal, melting of material, plastic deformation of the material. So casting will be related to melting of material and forming will be related to your plastic deformation of material. Machining will be related to material removal. So answer will be C. And these are the definitions. Casting is process of melting and shaping material. Forming is working of material to bend or roll material. Machining will be removal of material to smoothen the surface. Seventh question is, consider the following statements and select the correct option. So first statement is, pure metal melts at a single liquidus temperature. Eutectic alloy melts at a single liquidus temperature. Normal alloy melts at a solidus temperature. Answer will be 1 and 2 only, because this statement is incorrect, because normal alloy completely melts at liquidus temperature, and solidus temperature it starts to melt. So some portion will start to melt, but most of the metal will be in solid state here. So normal alloy will melt at the temperature range, while pure metal and eutectic will melt at a single melting temperature. So as shown here, at a equilibrium temperature it will start to melt and completely melt at this only temperature. Next is eighth question. Now cast iron and aluminum alloys are, your options are ferrous and non-ferrous metals respectively. Non-ferrous and ferrous metals respectively, or both ferrous metals and both non-ferrous metals. And this is the classification. Here you have engineering materials which are classified as metals, non-metals, ceramics, polymers and composites. Next question is, forming process is an example of addition of material, subtraction of material, equivalence of material and removing of material. So the forming of a material aims to give a particular shape following a series of a specific techniques, and this process makes it possible to reshape a part without adding or removing material and metallurgy, and manufacturers can carry it out thanks to various methods. Now these are the various methods that are used in case of deforming. In case of rolling, you will be having a workpiece in form of slab or plate in compressed between two rotating rolls in the thickness direction, so that the thickness is reduced, and the rotating rolls and draw the slabs into the gap and compresses it, and the final product is in form of thin sheet. Next is forging. In this case, the workpiece is compressed between two dies containing shaped contours. Now this is the shaped contours, right? Now the die shapes are imparted into the final part. Next is extrusion. The workpiece is compressed or pushed into the die opening to take the shape of the die hole as its cross section. Wire or rod drawing. It is similar to extrusion except that the workpiece is pulled through the die opening to take the cross section. Next question is a manufacturing approach which aims to reduce waste is known as flexible manufacturing, lean manufacturing, just-in manufacturing, or agile manufacturing. So these are the definitions which you should learn, and based on that answer will be lean manufacturing. So in case of flexible manufacturing, a workflow methodology aimed at reducing flow times within production systems, and lean manufacturing is a methodology that focuses on minimizing waste within manufacturing systems while simultaneously maximizing productivity. Just-in-time manufacturing is a production model in which items are created to meet demand, not created in surplus or in advance of need. Agile manufacturing is a way to create and produce things in a manner that is more flexible and adaptable than traditional methods. Now then we started with some lecture notes. So if you have any query, you can ask. If you have any query, you can ask. Okay, so next we started with the chapter understanding of manufacturing, in which we studied the definitions of manufacturing, need of manufacturing, types of manufacturing. Then we went through fundamental approaches of manufacturing, purpose of manufacturing, and what are the various types such as regenerative process, casting, forming, joining, machining. Then we went through advantages and limitations. So we went through 5 of the processes, what were their advantages and what were their disadvantages. Then we went through the materials part of the manufacturing, tried to understand how properties are important in various manufacturing processes. Then we went through the classification. So why we need to classify: to better understand, to organize, for easier naming. Now these are the various bases of classifications. These were the classifications that we went through. Yeah, that's all from my side. You can leave the meeting. We'll meet in next. Yeah, will please So just share your PPT, ma'am. So PPT I'll be sharing with the NPTEL team. I think they'll be providing you the link, Google Drive link. NPTEL will be providing you, yeah, with the links. If they don't, then let me know in the next class. Okay. If you don't have any query, you can leave. Okay, thank you. Thank you for joining.